everyone to our meetup for today. I'm Madison, and I'll be facilitating the meetup. Nicola, our research analyst, is going to be giving us her insights into our intelligence sales module and leading our meeting today. Last week, we had an open discussion where we explored and shared insights around our modules and how they can be applied to different industries and the impact that they've had. So this week, we wanted to take a closer look at one of our specific modules, intelligent sales, and see how it's transforming sales at scale. With that being said, I'm going to hand over to Nicola and ask her if she can start by painting this picture of, the current state of sales, the problem, and why we need intelligent sales.
Hi, everyone. Thank you so much for joining the session. I'm very excited for this, but a topic that I've just been delving into for couple months, so it's nice to just kind of put it all together and present it to people so that people can see its value. So yeah, like Madison said, we're going to start by painting a picture of some of the problems that sales is facing at the moment, specifically in terms of what the environment that customers currently exist in. So if you look at the climate around sales at the moment, you're dealing with customers that have very shortened attention spans. That's with the rise of social media, and you have people. There's stats that show that the average American is exposed to about 4,000 to 10,000 marketing messages a day, which is quite intense. It also calls to question why and how are they going to pay attention to a certain message if they are inundated with thousands of different messages. So intelligent sales seeks to cut through the noise and give your customers a reason to engage with your product. So all these things combined with ad fatigue and customer expectations on the rise in terms of personalization and making yourselves relevant to them, you need a system that can be agile enough to adapt to them and to a constantly changing environment. We're going to move on to paint a bigger picture of this. Just as an example, think of two colleagues that have just gotten a plane on a business trip and they arrive in London. Let's call them Mark and Lucy. When Mark lands, he has no way of contacting a driver. The two of them are separated. He has no idea where Lucy is, and he hasn't arranged a car beforehand. Lucy, on the other hand, gets a message from her service provider offering a 100 Rand bundle for roaming data, which then enables her to get access to Uber and get a driver. Mark eventually finds Lucy, hops in the car with her. He assumes that part of his plan includes roaming data, so he just activates data. At the end of the trip, he gets a massive bill for roaming data, and he's very displeased and immediately cancels his membership with the service provider and hops over to Lucy's service provider. This is an example of how we have these two opposing sales strategies. There's traditional sales, and then there's an intelligent way of doing sales.
Obviously, you've told us these two different approaches to sales, traditional sales and now intelligent sales. What does intelligent mean? What does that actually mean here in this context?
Yeah, so if you think about the meaning of the word intelligence in general, you might think that it's the amount of knowledge that you have or the amount of knowledge that you're able to acquire and retain. Intelligence is actually more about how you apply that knowledge and how you're able to take certain pieces of it in certain circumstances to let yourself adapt to that situation. Traditional sales practices, I think, have mostly focused on just getting as much information as possible, but haven't actually focused on how to apply that information in a valuable way. That's where the intelligence side comes in. If we go back to the example, you can see if you compare the two cases, in Mark's situation, his service provider had absolutely no knowledge of his new changed context. He was originally in South Africa, and now he's suddenly in a new place and he has a new need, and it didn't respond to that. It also relied on his initiative to seek out the service provider and their product. So maybe they did have an offer for roaming data, but how would he have known? He would have had to go to their website or whatever and go purchase it there. And this all results in dissatisfaction and gets people to switch over service providers, a much higher churn. And doesn't look good, especially since Mark decided to leave disdainful comments on social media about your service provider. On the other end, you have Lucy. Her service provider immediately picked up on her geolocation, saw that she had just arrived in a foreign country and that she might have a need for data. And having tracked her historical engagement with the products, they know that she needs to contact people all the time and she needs to have connectivity. So they personalized a bundle just for her and sought her out. And this convenience, people nowadays want convenience. They don't want to go through the extra work of opening another app and going to find what deals they can get. They want convenience. They want it right then. And that's what creates satisfaction and loyalty at the moment. Yeah, so moving on, the problem that sales currently faces can be split into two aspects. So it's first focusing on your input. Are you getting something that's relevant to your customer and personalized? And then also your output. Are you able to, from that input, derive value from your customer? So are you able to turn that intention into action? The first part, making your product more relevant to your customer, you need to gain enough knowledge and combine it correctly. You need to have a system that can take information about your product, internal knowledge about you and what you have to offer, the profitability of each product, and then combine it with customer knowledge to make an offer that benefits both parties. So it's not just creating a super good deal for your customer, which is a huge score, but actually is a score for the business as well. And then you need this to be adaptable because circumstances constantly change. So you can't, one offer might work in a certain circumstance, but might not a few minutes later. This all relies on being context specific and highly relevant to the person. But none of this really means anything if the offer that you give to your customer isn't made at the right time. We have a huge focus on real time. Just let me know if I'm making myself clear, Madison. I'm answering the question.
I see you've mentioned real time, and obviously we hear about it a lot and we talk about it a lot here at Ecosystem AI, but I think what would be really helpful is to understand what actually is real time. How quick is it? What is real time?
There's a distinction between real time learning and batch learning. You see batch learning in data sets where you have a large amount of data and your model gets trained on that large amount of data all at once and then updates it periodically. So it won't be in the moment. It might happen at the end of the day, end of the week, whenever's needed. Whereas real time happens in the moment. So your model takes small pieces of data and then updates and updates and updates as new data reveals itself. Batch learning is not necessarily bad. Real time is not necessarily better than batch learning. It all depends on the circumstance. You need to decide what is best for your business or product. Just to give you a little bit of an idea about real time, because when I was first exposed to it, I thought it was just in a few seconds it happens, but it's within a fraction of a second, so 0.02 seconds. You're able to call the API and return a response to your systems, which then enables it to engage with your customers in real time. So
I see we have a question in the chat from Janine. With the intent to have your own customer data only that you learn from and apply logic to be able to provide better output to a client resulting in better service, or is the intent to use customer data plus external big data to then add it to enable the decision making? This is quite a heavy question.
I think Jay, maybe you'd be better positioned to answer this.
Thanks, Janine. That's a great question. It's a big debate for us around what kind of evidence you can collect about a person's interactions with the real world. If you think of your behavior when you use social media or anything publicly exposed, you create a projection of your personality that you want the world to see and have a sense of some kind of reflection. So that means that if you go to your favorite Instagram, TikTok wherever you're going to post your content, and you've just had a coffee at a coffee shop. You might never tell the world about the fact that you drink coffee because you might be the juice person. You then make up a picture of a juice, you send it, even though you had nothing to do with what you've just done. And then you drive down the road, put fuel in your car, and you fly somewhere, and you only then project something about what you want the world to see. So that means that in our world, we've noticed, and especially with our big clients, that reality is not useful. And it gives us very little insight and intelligence around your realistic behaviors. But if I know that you've just swiped your card, you've just tapped your card, you've just been geolocated, you've just participated in activities that shows me a real life scenario of where you are in that moment. We take the time, place, and act data that gets collected by the company. You need to then add a social dimension to that, or what we call a computational social science dimension. Remember the social-based innovation from that era? You can apply that thinking on top of the data to interpret the evidence that the person has left behind. You need an approach where somebody can assist you with do the interpretation so that the interpretation is done continuously and reliably and consistently in exactly the same way. There's no point for people that behave like you gets dynamic scores. And that's why you'll see that, and especially when we talk about the AI world, is that it's not a generative problem, it is a predictive problem. You need accurate and precise algorithms to get your score done. Then you can apply linguistic tools to expose it to people, but you want the reliability of the actual evidence that the person leaves behind. We would normally use private data and work with clients in producing an interpretation using social models and various behavioral science models, behavioral economics, computational social science models, to interpret that so that it can be applied in an archetypal context or some kind of abstraction. There are places where we do use public data, so it's not always that you don't. So an example is we do use, like in a medical profession, there are reports that are published around, you know that like in the insurance world, you know that well. So if you think about certain ways in which certain drugs are deployed, there are public data sources that can be used in certain cases. But for the sales scenario, we find that the more evidence you collect as a company, the more reliable your outcomes are. And that's typically why it looks like that.
Sorry, I have not been in a meeting like this before, so I don't know if I can or should ask questions or not. That's why I didn't put up my hand or anything. Perhaps let me explain a little bit more around my question. If you take as an example a company called Omniscient that collects quite a lot of the data from ShopRite and Checkers, through anonymized data, you can start picking up trends. Somebody that has bought shampoos and soap that does not exceed a certain size is more likely to travel. It gives you an indication that they've been on a flight or planning to go on a flight. Somebody that buys chlorine on a monthly basis more likely has a pool, gives me a reassurance in a completely different industry like home insurance that the probability of them looking after their house in a more efficient manner is higher. So that's where my question stems from, in the fact that we're doing it in various other ways as well. As an example, if you look at life insurance, there is actually a company that collects every single transaction that goes through on your record. I have taken Disprin, I bought it from the pharmacy, I've gone to see an ophthalmologist, I've gone to see a cardiologist, whatever, collects all of that and builds it around your profile, and then engage with you instead of sending you to an ophthalmologist or asking you a question about your health. I can actually just look at that data, know that you're taking medication that is heart medication or something, and therefore I know you've got a higher probability of exposure to that. So it is looking very much at probability cases rather than reacting to something. And I'm not really referring to your social media stuff, but actual data. So my question was then, would you be reliant in this sales tactic only around the data that the client collects themselves, or the interaction through different data sources that can provide a richer picture to be able to make that intuitive decision? Because in theory, okay, now looking at certain laws, you cannot collect excessive data from a client if you don't have legitimate purpose, legal basis, and you need to apply minimality. If you've applied that as a company, how do you then still act within the law, but obtain additional data that will provide you with an enriched picture to provide intelligent sales tactics to your clients?
So what you find is there are a bunch of companies that do generic aggregation. I think we've been super fortunate, Janine, that the clients we've been working with, when they do private partnerships, like when first round did a partnership with ShopRite, or, if you think about Discovery do partnerships with their partners, there's a basket level agreement between those companies. So that means that you reliably get based on the opt-in agreement. If the person opts in, and that's what normally happens, especially with loyalty programs like the VodaBucks or the eBucks or the Discovery Points. When you opt in, it's outside of the regulatory framework of where that instrument is, and you opt in based on the behaviors, especially when you do surveys in the context of the data set that can then be shared. But you still augment. So what we found is that you augment if you can find evidence that's reliable. And when we run, to give you an idea, Vodacom publicly published it now that there are 11,000 data points collected per subscriber. If you look at it, the number is probably more like 3 times that. So that means we run autoencoders, deep learning models, figure out variable importance based on certain purchase behaviors. We're trying to understand which key attributes contribute to understanding enough about you. If you take an entropy score or an autoencoder's final score, you've collected enough evidence about a person's behavior to take a certain set of attributes. For example, in banking, there's a direct correlation between, and actually it's disproportionate, the number of accounts you hold against your churn indicator. It's impossible. You can predict as much churn as you like. It actually makes no difference. If a person has got more than 3.5 products with you, they won't churn. It's too painful to take their mortgage, their vehicle asset finance, their current account, and their credit card and move it somewhere else. You won't. So that behavior that creates that variable importance only can be determined once you run it across entire data sets with the augmentation, where you include the external data sets. So definitely, yes. No, I get it. I get now what you're saying. If you take generic public data, it's not reliable. But if you take aggregators that sell you those data sets, they definitely contribute, yes.
So in other words, looking at this sales strategy, the information science behind it is actually one of your key driving factors to enable the organization to have a smarter sales strategy.
It's a bit like, remember your information and data architecture stuff that we spent years doing?
That I still use.
I promise you, that work still today, our number one obstacle. If I could just take people and say to them, please phone Janine and let her fix the stuff for you.
But why don't you?
I'm telling you, it is still exactly the same problems, because they still say, remember when we're trying to do like a solvency calculation?
Yeah.
The problem wasn't the calculation. The problem was the fact that they can't find the evidence to get the calculation done. So it is still exactly, no, I get it.
Sorry for the interruption, Nicola.
No problem at all. I think that actually it's still very much within the realm of what I'm talking about, which is about different parts of information that businesses already have. It's just about applying it in the right way. That brings me to my next point, which is the second part of the problem, and actually turning the intention that your customer might have into actually doing it. Part of this process is also maintaining this relationship where the customers are active and lowering churn. And one way of doing this would be through upselling and cross-selling, bundle offers. We use several tools to do this, but intelligent sales is only as powerful as the way that you implement it. So all these capabilities that intelligent sales has is not going to be much use in certain aspects of your business, but can derive massive profits in other areas. So it's all about where you identify your pain points and how you implement the tools. One tool we could look at is rates of learning. There's a differentiation between low rates of learning and a high rate of learning. Rate of learning is basically how quickly your models adapt their parameters based on data that they're exposed to. So a model with a low learning rate requires like large amount of data for learning, and when some data point deviates from the mean, it won't mean much to a low learning rate model, whereas a high learning rate model will take a fleeting trend and apply a lot of weight to it and adapt its approach to that. So if we think about the example that I brought up earlier, the model that Lucy's service provider was using was one of high learning rate, where there was a sudden change in her environment. She was in a new country and it adapted immediately. Whereas with Mark, they're using historic data of his purchases and the places he goes, and doesn't see any meaning in the sudden change in his environment.
Nicola, can I ask, are there any situations where, I mean, you've told us here where a high learning rate is really important in this anecdote that you've given us. Are there any examples of where low learning rates would be beneficial?
Yeah, so here again, it's about how you implement it. So if you think about an example with the stock market, if Mr. Elon makes a tweet and people suddenly buy up a certain stock, a model with a high learning rate would purchase that at an overpriced rate because it will see it as something very important that it needs to respond to. Whereas a model with a low learning rate would look at the bigger picture and the general trend and see that that is just a fleeting moment and that it will most likely return to regular patterns. So you have to decide based on what your customer behavior is, what rate of learning you'd like to use. On to the next one. This is kind of how you would learn.
Nicola, I'll give a quick example to everybody. If you had to think of the rate at which you would buy a car or the rate at which you would get a new mortgage, and you think of the distance and you think of the time distance between interactions of whatever you do with the institution that you are engaging in, and then think about the number of times that you've swiped your credit card in the last week to buy coffee, to buy food, to put in fuel, to do many of the other things that you have done. So maybe the way to, as a mental hook, this for rate of learning, is to think that if I wanted to build a model to drive a recommender to recommend something to you to act on when you're busy doing a mortgage application, means that you might only do that once in your entire lifetime. Or if I look at the countries, in some regions it's shorter, it's about 9 years. South Africa, it's about 7 years. The UK. So that means that your rate of learning is incredibly slow. So you cannot use a theory that relies on many data points to drive interaction. And maybe back to Janine's point, it means that you need augmentation. They're trying to get an understanding of a societal perspective of how the data is collected. Whereas if the rate of learning is high and you engage continuously, like we find that in some telco clients that people might buy a 50 megabyte bundle, let's say twice a week, compared to somebody that signs up for a contract twice a year. You need to think about the data points that are based on the interaction that gives you evidence of the person's behavior as the concept of rate of learning. So I thought, Nicola, it'd be useful for people to know, maybe like a thinking hook to separate them.
Yeah, thank you for that. So I think a lot of like determining which tools to implement in which areas, you need to know a lot about your customer's behavior, and a way you can do this is through experimentation. This graphic shows several ways you can experiment on engagement. To clarify, experimentation means you apply a change to the interaction with your customer, something that isn't the norm, and then use that response as an input to the model, which informs your next action in their interaction. This can take many forms. You can do mass engagement experiments that deal with the architecture of the website. We have different banners or different messaging styles, different buttons. So it focuses on interaction options with your customer and tracks how they interact with the platform. Once you know more about your mass market, you can hone in on personalization and get a grip on what your customers' preferences are. So you can recommend certain offers, products, and then register those actions. And there's no such thing as a bad impact, because even if the response from customers is negative, it shows that you are targeting a place that can be influenced. But that means you just have to adjust your response and flip it the other way. I think no change is definitely worse than a bad change. You can also do it with journey experiments. You're looking at what your customer's engagement fingerprint is, because every customer is unique, and where they go first within a web page. Do they go check their balance first, or do they go to buy airtime first, and where do they go after that? So you can track that and kind of play around with that as well. And then cross-selling and upselling in language experiments, and then you can track that against historical behaviors as well. And also call to action experiments, seeing how your customers respond to certain behavioral nudges, and you see if you can retain them from that. This is just a bit of a bigger picture. in terms of what happens if you don't know your customer versus whether you do know your customer. So a lot of businesses are currently functioning in the bottom left section, which is where you have an existing market that you know, and you have an existing product that you've been selling to this market, and you have a wealth of historical data, so you're able to cross-sell and upsell your products to this market. Static models generally are a lot more suitable here because you're using large data sets that don't change a lot. You have a very constant trajectory. Moving into the gray section, this is where you're combining, maybe you have an existing product that has worked in a certain market, but you want to expand it globally. Then you have this combination of a known product with unknown markets, or vice versa. You have a known market, but you're trying to expose them to a new product. Both of those require a certain level of experimentation and just trying to get to know what sticks and what approach you can use to get people interested in a new product. In the blue section, this is the part where we're quite interested in a new product and a new market. This is useful for businesses that want to expand their products into a new market, create something new, and derive value from it. So here you'll need dynamic models that learn constantly. You have no historical data, so you need a way to get knowledge from an unknown market. This is where we thrive. This is showing the journey a customer takes once you go from that blue zone into the known zone. So discovery and onboarding is kind of about how to get to know your customer first, and continually engaging and learning from them until you're able to turn intent into action, and then to continue a relationship with them by upselling, cross-selling, and reducing churn. So, and a very important part of this is kind of knowing the sweet spot of engagement with your customer. You know, how much effort is beneficial and how much is actually going to push your customer away from you. This brings us to the concept that comes from marital qualms. In any given relationship, when you meet a new person, there's always an initial interest, novelty. You have a spike of feeling that gets you interested, but this is not maintainable. It's not going to work to constantly flirt with your customers. There needs to be some stability in the relationship. Sentimental equilibrium is where the amount of effort that you put in reaches the most beneficial amount of feeling from your customer. And it's also about a balance between knowing too much and knowing too little. If I can tell that my data is being observed, it would feel like an invasion of privacy. We need to recognize that as well. We can recognize this through intelligent sales because of the background of tools that we apply with computational social science and interaction science and behavioral analytics.
Nicola, on this point, do you determine that sweet spot prior to engagement or on the start of engagement, or do you at which point do you determine what that sweet spot is? Because you can carry on with it for 3 months or 3 years, and a lot of people will 3 years later still not see the billboard at the front of their house. So, you know, where do you find that sweet spot? Typically, we look at fail fast, and we've got a capital expenditure amount that we commit to small chunks of projects, where we would say, let's put $1 million down. And if we fail, we only lose $1 million. It's just $1 million. But we only have a certain small achievement that we need to reach for that $1 million to prove successful or not, to determine if we go on and do a second thing. So that would be interesting in terms of where do you find, where do you determine which you've reached that line?
Okay, thanks for your question. I think I'm going to hand over to Jay. He's the master of this.
Madison, Nicola, you know what the answer is, I think. Yeah? It's fine. I'll go for now. So the approach here is, can you learn from how humans form relationships, especially when those relationships are formed one-on-one? And this particular model being a spousal dissolution model, meaning that the researchers created a mathematical model to say that the relationships that are successful have found an equilibrium around the push and pull, the agree, disagree, the happiness, sadness, and at some point, people find a rhythm they get comfortable with based on who they are as a person. We found that intriguing because if you think about how people talk to you from a brand point of view, if I over communicate, you feel invaded and irritated. If I under communicate, I feel ignored. So the equilibrium is a model that converges based on an individual. So the idea is that if you look at the 1, 2, 3 on the bottom, that shows effort in attention. What they concluded is that most relationships fail because people get comfortable or they get over attached. So that means somebody will tell you what to do the whole time, and now you get mad because they're trying to control you. Or somebody does too little, and then you also get mad. Finding the equilibrium is saying that, can I get the pace and the content of how I interact with you at a rate that is relevant to you based on the stage of the life that you are in? And that's why we normally find
that's quite an important point.
Yes, and that's why you have to use a dynamic model. What Nicola was saying earlier, you can't use a static, because static models historically makes an assumption that everything that has come prior to this moment is evidence of what you're going to do in the future. But if I get the model to converge with a discount factor and various other mechanisms based on your behaviors over the last days, weeks, months, depending on the rate of learning, your equilibrium could be different. So that means that, you know, if you think of, I mean, I've got a classical example in the banking. I won't give the bank's name away, but, you know, I'm still overbanked, as you know, Janine. So one of the banks that we know well, I used to use 2 of their credit cards very actively. Actually, when I used to commute to London, I spent a ton of money. And then what happened is that I stopped spending on them, and the account that used to pay the bill, then also eventually, I mean, I think I closed the account in South Africa. My bill came back 26 Rand 50, and they spent about 50 phone calls trying to collect the 26 Rand 50 after about 5 years of not using them at all.
I know exactly which bank it is.
They never spoke to me. They never communicated with me. And as soon as it went 26 Rand 50, they phoned me, they emailed me, they WhatsApped me. And actually, back then I figured, well, I'm going to need to get my 26 Rand 50s worth. So every time they phoned, I answered the call and I speak to the person on the phone saying, how's your day? How's it going? Tell me about, how's the call center? How many people are there? And I kept them while I was busy working, just, you know, speaking to them and making sure that they're clocking up the hours of whatever. And then they said, well, sir, do you need to have an arrangement? I said, yes, please. 12 months. I said, what do you mean? I said, I want to pay over the 26 Rand 50 over 12 months. Please tell me how I can do that. Yes, sir, I'll get back to you. Then they get back to me with documents and I said, no, it's fine. I'll just pay it. The question is this, though. When did they know that I were not using that card? They probably knew the very first week after I stopped spending consistently.
Right.
And they did nothing about it. That means this can automate something that an enterprise finds almost impossible in its DNA to figure out, because it's too much work to say that every customer must be treated as an individual.
Yep.
The algorithm helps you figure out what is good for you versus somebody else.
So it's a unique sweet spot per client with their behavior that demonstrates where that sweet spot sits.
Yes. And then if you show high degrees of consistency, you can then use models. If it shows high degrees of volatility, you use a dynamic model, but you then still run experiments to say that I know that I am in the right way of effort and attention. So you need to show some novelty. It's a bit like arriving at home with flowers when you're not supposed to. Well, then it might also be interpreted wrong, but who knows? But the point is, though, is that you have dynamic ways in which you can then run experiments that then helps you with your explore part of the algorithm. Yeah.
Cool.
I think it might also be useful to determine what your definition of success with a customer would be as well, and then trying to get your customers as close to that as possible. I mean, that's going to look different for each customer, but it would be useful to create some kind of problem statement of, if the customer is happy, this is how the customer behaves, and we're going to try and get each customer as close to this as possible. And then you do that by experimenting and adjusting your approach every time and learning from it.
Nicola, what might be useful in the future is to talk about the happiness hypothesis.
Yeah, so yes, sorry.
I just wanted to say, we've looked at all of this now, and I just wanted to ask if there's any examples where we can see this in action and where we can see the value coming through.
So before I get to examples, I just want to reiterate that the way that you apply each tool is where the value is derived. You can implement it in a recommender, but if that's not suited to your business, then it's not really going to do much. I think we've kind of covered this. I'm going to just move on because we are also short on time. Straight to the example. If you have a customer that logs into an app or opens an app that doesn't log in yet, they get to the generic page. And at this point, your systems wouldn't know anything about your customer. They don't know the customer ID at all or any of the details that they might have entered into their account before. But as soon as your customer logs in, you're able to kind of do a customer lookup and get a vague idea of their preferences and the history, and put together the first part of the landing page for them with recommendations and structure that is personalized to them. And you can do this with a cold start. If this is a new customer and you don't know much about them, you can create certain layouts or offers, and as they scroll, you learn from their interactions. Where are they hesitating more? What are they clicking on? As you go, but if you see that block with the images in the third slide, those will update as the person scrolls based on their interaction before. Those recommendations might look different. This is real time in practice, and within milliseconds, it will be different. I think that kind of outlines intelligent sales. This is just one implementation of it. It can be used on web pages or messages, chatbots, or recommenders. Only certain components of it can be used. It all just depends on what's suitable to your business. So yeah, thank you very much for being a great, fairly tame audience.
Nicola, I have a question on that last bit. It was something interesting that you mentioned, how there's this generic screen that you see before a customer logs in, and then obviously when a customer logs in, there's a slightly different journey. Could intelligent sales be applied in both scenarios? Do you always have to know your customer in order to provide them with intelligent offers? Or is there a circumstance or a situation in which, yeah, like unknown before they come in space, but actually be just as valuable?
Yeah, well, I think that's where the dynamic models come in. Even with a generic page, you can still track behavior on that page. So even if you don't know anything about the customer, you can see how they're behaving on the page, and it adapts as you go. You can store that information. When you have historical data, it enriches it more, but it doesn't mean that you're not going to be able to personalize things. You can still use new data and adapt accordingly.
Thank you.
Dynamic approaches called online learning or continuous AI or continuous machine learning is definitely a separate class of problem to solve than the classical discriminative versus generative-based model approaches. The reason why they're different is that if you have a time window, and let's take the example, Nicola just gave now in that answer, and let's say you want to track visual elements on an interface. We did this for various situations, gambling in the US and a few other places, where if a person comes into a website and the menu option they are looking for sits off the right panel, and that option is maybe where they have to go check their balance, or it's something that is not in the context of the UX design considered to be important. The classical way would be that you do static design. You make an assumption that the persona that you've used to create the design is the ultimate representation of what they're going to be doing. If you want to include a dynamic model and you wanted to converge on menu item sequence, let's say that you want to get menu items that a person clicks on more often than others to converge to the left, only one of those items must converge, the rest must stay the same, so you don't create support or conflict later on. You can set it like that. And that is, in our world, a fairly easy configuration that starts with no data. You configure it, you set the converging rules, and the first time the person comes in, it's a cold start problem. So that means they will connect, and you will randomize the fact that the score will keep the menu item on the right. But let's say the person comes in a second time, and you set your threshold of learning at, let's say, 5 interactions. By the time the person gets to 3 and 4, the model will start realizing that this item needs to be on the left. As soon as they break through the threshold, if the person in the 6th or the 7th or the 8th interaction click on other items, it won't discount it immediately. It will keep it there. You can set dynamic parameters to decide the interaction without initially knowing anything about you. If it's on a website, let's say you want to do it in more of a public without knowing anything about the person, then it will just converge based on common preferences. And that's what the gray block means, common preferences versus a person's specific preferences, even if it is cold start when I know nothing about you. So the cold start would use probabilistic or distribution-based methods to find out what the most optimal item is based on the situation that you are in at that time. Yeah.
Is that also kind of an application of how static and dynamic models can be used in the same circumstance? Yeah, because I think that's a true depiction of intelligence, knowing in which instances you should be using static model and which instances it should be dynamic. And that's not something that you necessarily want to have to dictate to your systems.
Yeah, and I think that's when you probably will use our ecogentic framework as well, because the ecogentic will help you to figure out if you're going to have an agent-based framework, that the AI agent will work out if there are additional extraneous behaviors, or if you want to make it more reliable, you'll use the network selector. And the network selector will say, let me only use the static model if I have no evidence or not enough evidence about your behavior. And as soon as I get to a point where there's a threshold of enough evidence, then I'll go to the model that is then more, either algorithmic based or dynamic based. So we separated our world into what we call static models, dynamic models, and generative models. And the idea behind it is that when you've got lots of data and reliable, you work with static. When you got lots of language and common criteria, you work with generative, and you work with dynamic almost under all other situations. It's a bit like Nicola's graph from earlier with the product market matrix, is that many situations you are in, you don't have enough evidence to actually engage, and you want to make it dynamic. The dynamic will show up the fact that there's maybe somebody that is highly ritualistic that will then create evidence to make it static. And you can decide in a network selector what that must be. Yeah.
Yeah, so through very little interaction, you can start predicting the behavior, which would mean that you would switch between your model types as you get to learn about the individual through little data points.
We call it a loosely coupled stacked ensemble. The reason why we call it loosely coupled is that you could either, if you look at a one end, a rule to say that if X used model or if Y, or you can have it or you can have it on the opposite end to map it onto a distribution or use a linguistic model or something else to decide what I must do. So you can decide where you draw the threshold. In most cases, we find that if you use information science, it's far more evidential because you know that it's reliable. Yeah. Especially if you get to models that need to be explainable, like in fraud or abuse, like in medical fraud and abuse practices. You need to explain why it is giving you the answer that it's giving you. Then you have a different approach than if you randomize it to help you to sort out some of the answers. Yeah.
Are there any other questions? Kind of want to open the floor up.
Good job, Nicola.
Thank you so much.